So here is question number 16, everyone. A capillary tube is dipped in water as shown in figure. If P0 is atmospheric pressure, PA and PB are pressure at A and B respectively, then we have to compare this A and B pressure with atmospheric pressure. Now first of all, this P is at the same horizontal line as P0, and according to Pascal's law we can say that PB equals P0. Next, for A, this is the case of excess pressure. Suppose this is the bubble. Here pressure is P1, here pressure is P2. So the excess pressure P2 have by P1 given by P2 equals P1 plus 2S by R, where S is surface tension. The same way here, P0 is at the excess pressure. So we can write P0 equals PA plus 2S by R. So definitely from here we can say that P0 is greater than PA and PB equals P0. And if you find the option, we can say that option number 3 is perfectly matching, where P0 is greater than PA and PB is P0. So we'll go with option number 3 only. Now move on to the next, that is 17 number. This is question number 17, everyone. Triple point of water is a factual kind of question. We must be knowing that triple point of water is 273.16 Kelvin, where all three states coexist. So triple point of water is 273.16 Kelvin. So that's why we will go with option number 4 only. Now move on to the next, that is question number 18. So here is question number 18, everyone. Water is filled up to the same level in two identical flasks at 4 degrees centigrade temperature. If one, says A, is heated while B is cooled, then we have to neglect the expansion or contraction of the flask, and we have to talk about the water level in both flask A and flask B. We know very well that the variation of volume of water in any flask with temperature will be something like this. And it is clear to all of us that at 4 degree temperature, water shows anomalous behavior. Means if we go above 4, volume increase, or if you go below 4, volume increase. Means at 4 degree temperature, density is maximum, volume will be minimum. So in both the cases, whether we are rising the temperature or we are decreasing the temperature, the volume will increase. So that's why the water level in both flasks will rise. Since volume will increase if temperature is increased or decreased from 4 degrees centigrade. So therefore volume in both flasks increases and level will also be increased. So let us go to the options. Water level in both flask A and B will rise. Definitely we have got the option number 1, which is absolutely correct. So we will go with option number 1 only. Now move on to the 19 number. This is question number 19, everyone. A Carnot refrigerator has freezer at temperature minus 8 degrees centigrade. The coefficient of performance of refrigerator is 5. Then the temperature of surrounding in which heat is rejected will be what? We know very well for Carnot refrigerator, the coefficient of performance is given by T2 upon T1 minus T2. Now COP, which is already given here, 5 equals T2 upon T1 minus T2. Cross multiplying gets us 5T1 minus 5T2 equals T2 So therefore T1 will be 6 by 5 times T2. Now T2 is given in the question, that is minus 8 degrees centigrade, but we have to write in absolute temperature, that is in Kelvin. So 273 minus 8, that's why this will be your T2. 273 minus 8, that is 265 Kelvin. Putting here will get you T1, that is 6 by 5 multiplied by 265. After solving, 5 5 ja, 5 3 ja, that is 318 degree Kelvin. That will be T1. Now let us find out the options. So there is no option of 318 Kelvin and all the options are given in degree centigrade. So that's why we have to convert it. So T1 will be 318 minus of 273. That is 45 degree centigrade. So we can say that we have to go with option number 2. 45 degree centigrade. Absolutely correct. Now move on to the next, that is 20. So here is question number 20, everyone. A gaseous mixture consists of 16 gram of O2 diatomic and 16 gram of helium, that is monatomic, at temperature capital T. Neglecting the vibrational modes, the total internal energy of the system will be what? We know very well that the internal energy at any temperature T is given by NCV into T, where N is number of moles, C molar specific heat capacity at constant volume, T absolute temperature. Now CV for diatomic gases like O2 is 5 by 2R. On the other hand, CV for monatomic like helium is 3 by 2R simply. Therefore, the total internal energy of system will be what? N1 CVT plus N2 CVT. N1 for oxygen, it is number of moles 16 by 32. Mass upon molar mass multiplied by 5 by 2 RT, plus N2, that is for helium, 16 divided by 4 CV, 3 by 2 R multiplied by T. Now let us solve it. 16 2 ja. So after solving, we will get 5 by 4 RT plus 6 RT, that is 29 RT divided by 4. That will be the total internal energy of this system. Option number 4 we have to go with. Move on to the next, that is 21.